Okay, Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi and good evening to all my beloved students. Alright, so tonight we continue. Okay, we look at the third subtopic, Form 5, Chapter 1, okay, 1.3, Forces in Equilibrium. Okay, so are you ready? Can hear me clearly, huh? Alright. Okay, so forces in equilibrium. So before this, okay, we just recap. So before this, chapter 1.1, 1.1, we learned about resultant force. Resultant force, correct or not? First subtopic. And then second subtopic is resolution of force. Resolution of force. Okay, resolution of force. So the third one is forces in equilibrium. So these forces in equilibrium, it actually combine first and second subtopic. Alright, so you need to know first and second subtopic before you go through this 1.3 forces in equilibrium. Alright, so what is the meaning of forces in equilibrium? So you can look at your textbook. So object is said to be in equilibrium of forces when forces acting produce zero resultant force. Okay, so we have learned about resultant force, but when we say that the system is having forces in equilibrium, so it means that the resultant force acting on the system will be equal to zero. Okay. So when the resultant force is zero, so maybe we recap. Resultant force. So when resultant force is equal to zero, okay, resultant force is actually the net force. So when resultant force is equal to zero, so from the formula of resultant force, okay, F net zero, so means that MA is equal zero. Okay, so M is mass, right? So mass cannot be zero. So this one cannot be zero, but definitely if the net force is zero, it means that the acceleration is equal zero. All right, so when will the acceleration equal zero for a system? When will the acceleration equal zero? What are the situation where A is equal zero? There are two situations. Correct. All right. So one is when the system is stationary. Okay. Another one is when the system is moving in correct constant velocity. Okay. So because from the formula of acceleration, so we know that A is equal v minus u over t. So v is final velocity. This is final velocity. This is initial velocity. Okay, so when v equal u, okay, means that acceleration will be equal to zero. So this is when the system is moving in a constant velocity. So there is a value lah, constant velocity. So let's say v equal to u at all time the velocity is 10 meter per second. So it means that v is 10, u also 10, so 10 minus 10 is equal 0. So it means that 0 divided by t, you will still get 0. Okay, so this is the first situation. The second situation is where the object is stationary. So it means that v equal u is equal 0. Okay, so we have two situations where the acceleration is equal 0. Okay, this is stationary or at rest. All right, huh? So must remember this. So when the acceleration is equal 0, so we said that the net force is equal to 0. So means that the system is having equilibrium, means that forces in equilibrium. Okay. This one must remember. Two situation. Okay, write in your note. Mesti ingat. Zero resultant force, two situation. At rest. Another one is moving in constant velocity, right? Now, look at this situation. So the object now is stationary, okay? So the vase now is stationary, yeah? Okay, not moving. So in this case, you know that the force acting on the system, we can label. So we have the weight, okay, pulling downward, acting downward, and then there will be another force acting upward. Okay, so this is known as the normal reaction. So in this case, since the object stationary, yeah, so we say that the forces acting on the object now is equal 0. The forces acting on the object now is in equilibrium. So means that the net force is equal 0. So in this case, R will be equal to W. The magnitude will be equal because they are acting in opposite direction. Can see, right? W 90-degree downward and then R 90-degree upward. Okay, so the magnitude of the two forces are the same but in opposite direction. Okay, so and we said that the resultant force, net force, equals 0. So we have another system where we have a lamp here hung from two string. Okay, lamp. So we have the lamp and then there are two string here. One, another one is here, two string, and the lamp is stationary. So when the lamp is stationary, so we can say that the forces acting on the lamp are in equilibrium. Okay, so we can label the forces acting on the lamp. In this case, we have this one, W 90-degree downward. Okay, because we know this will be the ground, so W will be always 90-degree to the ground, right? Like that. So easy to label like this lah. Okay, and then in the string there will be another force, what we call as tension. Okay, so this is tension and then this is another tension. Okay, because we have two string here. All right, so in this case there are three forces. So we have W, T, and then another tension labeled as P. Okay, in this case, you can see obvious the magnitude are not the same, right? So this is 4 Newton, this is 5 Newton, this is 3 Newton. Okay, although the magnitude of the force acting are not the same, okay, and you can also see that the direction are not really opposite, just like we have, it's like this. Okay, so this one can see T is this direction and then P like that and then W like this. But in this case, the resultant force is actually equal 0. Why? Because the lamp is stationary. Okay, so for the cases like this, we need to draw what we call as a triangle of forces. Okay, triangle of forces like this. Okay, so three forces acting on the lamp, so we can draw triangle of forces to represent the forces acting on the lamp. Okay, how do we draw the triangle of forces? Okay, so triangle of forces actually drawn to show the equilibrium of the three forces acting on the object. So when we draw the diagram, the magnitude of the three forces will be represented by the length of the triangle, and we need to draw them in sequence, okay, according to the direction of the force. So we don't change the direction. And you can see, right, this is the example of the triangle of forces acting on the lamp just now. So can see now W. All right, so can see W is 90-degree downward. Okay, we need to draw the arrow. And then P, see here? So this is W just now, downward. And then P is to the right, horizontal to the right. And can see? P we draw at the end of W, horizontal to the right like that. And then T, look at the angle. So T is drawn like this, right? Okay, slanting like that. So can see that here, this is T. So when we draw like this, so this is what we call a triangle of forces, where we don't change the direction. Okay, we don't change the direction. So this is one of the example, and we can actually draw another one. Kejap, oops, need to rub this off first. So I think I better use other color. Let's say I label this as, let's say, okay, P like that. And then this is W just now. And then T. Okay, so when we draw the triangle of forces, we need to start with one force first. Let's say the easier one here will be the one that is either 90-degree downward or horizontal. Okay, means that either W or P. So let's say we start with W. So we can do like this. All right, so that is W. Then P, I need to draw at the end of W. If let's say the diagram is drawn in scale, you can see here, and then T will be drawn at the end of P. So if we draw in scale, okay, since now it's not in scale, right? That's why you don't see the triangle is a closed triangle. So it means that I need to lengthen T. So I just redraw T lah, huh? So this one, I think I just remove this first. So means that my T should be like this. Okay, so if let's say we draw following scale, so you will get a closed triangle with one direction. Can see, right? W, P, and then T. The direction they don't collide. Okay, so it is what is it? One way direction, jalan sehala, like that. Okay, so let's say I don't want to start with let's say I want to draw W first. Let's say I just give you an example. W first, then I draw T. Need to draw T at the end of W, and then P draw at the end of T. So this is another triangle of forces. So this is your P. P is here. Okay, so this diagram and the previous diagram is still, what I mean is uh, either you draw this diagram, this diagram or this diagram, both are correct. Okay, can we draw other diagram? Let's say we start with, because just now I start with W, right? So let's say we start with P. Okay, let's say we start with P. P, this is P, and then continue with T, like this. And then continue with the third one, which is W, like this. All right, so this is W. So means that you will get this diagram again. Okay, so means that this and this are all correct. So it up to you to start with any side of force. As long as the second one you draw behind the first one, the third one you draw behind the second one, you will get the correct triangle of forces diagram. So this one okay or not? Boleh faham? Can understand or not? Boleh, ha? So look at this page. So there are three situation given here, three example. So all the forces already labeled. So in exam, they normally don't label the force. You need to label yourself. Okay, just like this, showing a box stationary on an inclined plane. So the forces acting already labeled. So um, normally we don't give you label diagram like this in exam, so you need to draw you need to label the diagram yourself, and then after that draw the triangle of forces. Okay, but now the forces already labeled for you. Okay, but it's okay, so we can try to draw the triangle of forces here. So in this case, okay, if you look at FR, R, and W, the easier one to start with will be W. Why? Because it is 90-degree downward. Okay, normally we choose either like this, if you have, okay, 90-degree downward, or horizontal. Okay, can be left to the right or right lah, depends on the question. So in this case, we start with W. All right, then can see so at the end of W, you can continue with FR or R, up to you. Okay, let's say we continue with R. So R will be here. And we don't change the direction. This is R. And then FR will be like this. This is FR. So if you draw your diagram in scale, you will get a closed triangle like that. So you see, we don't change the direction. R is still the same as this. W is 90-degree downward, and then FR is here. Boleh ha? So if let's say we don't want the second one to be R, let's say we want it to be FR. So will we get the same the correct diagram or not? Let's say so this is your W. Okay, FR, draw the second one. FR, put here. You see, I don't change the direction. Direction still the same. Okay. So means that the angle, the slanting angle must be the same lah. So this is FR. And then R, I draw behind. So means that as if I copy this and then paste here. Can see or not? Label here. So still, I get a closed triangle with one direction. Kan? W, FR, R. So the direction does not collide. What I mean, collision means like this lah. Let's say, alright, so means that these two are not in one direction. So this is the collision. Cannot lah, this one salah. Understand or not? This is okay because they does not collide. So when you are able to draw triangle with one, I can say one way direction arrow for forces, so that is a criteria for forces in equilibrium triangle of forces. Boleh? Do I confuse you? Okay or not? Boleh ha? Alright, so we look at the second diagram showing picture frame hung on the wall by string. So there are, in this case, I think this is one string. Yeah, one string, you hung it on the nail on the wall. So label the force acting on the system. So in this case, when you are asked to label the force acting on the system, must remember this. Okay, W. So this is the first one lah. Normally will be 90-degree to the ground. Okay, so this one no problem, 90-degree to the ground. This is your W, and then there will be tension in the string. Okay, like that. Label for you already, and you can see here there is an angle. So when you draw the diagram, the triangle of forces, the angle must be correct. Okay, so if let's say here is 30-degree, so here will be 60-degree. Okay, 60 plus 30, 90, right? Like that. So Here will be 90 degree lah. Okay, faham? So this angle, what is this angle? It will be the same as alpha. Okay, now, so when we want to draw the triangle of forces, as usual, okay, pick the easier one first. Actually, you can start with T, no problem. You can draw like this T, then you continue with W, boleh. Okay, but then this will be um, uh, it will be so much easier if you start with the force that is 90 degree to the ground or horizontal. Okay, but in this case we don't have horizontal force, so we need to start with W. Okay, so the way you draw will be W, and then T, we have two side T. So to make it clearer, I label this as T1, T1, T2, or maybe I just change color lah. Sekejap. Change the color first. Alright, so W, okay, so this is W, and then T, and then another T. Okay, so cikgu just copy this. Okay. Why moving like this? Technical error. Kejap. Okay, so let's say sekali lagi class I try. Cannot. Alright lah, so I just use the same color. So let's say this is W, and then red T. So this one cannot hop. Alright, so this is the T, the red T like that. Okay, and then the purple T need to be drawn behind the red T lah, huh? Okay, do you realize that I don't change the direction? Direction is still the same. So W downward, and then T here, and then this T is here. So the direction are not changed. But when you draw the diagram, you need to label where is the angle. Okay, so here, in this case, this is alpha, right? Where is alpha? So alpha is here. Can see not? Boleh? Or if let's say they give you the value, let's say the value here is 20 degree. Here also 20 degree. So inside here, it's either I label it here or I label inside here. So this will be 70 degree. Boleh? And then what would be this angle? What would be the angle according to the diagram, if you look at the diagram? So one way to know the angle would be you can draw here. Can see? So this is 20 means that here will be 70. This is 90, right? So means that this angle is actually 70 degree. Okay? Boleh? Is this 90 degree? Correct or not? 90 degree here? No, right? So it doesn't mean that all the time will be 90. Sometimes it is 90 degree, but in this case, this is not 90. So how do you know what angle is here? Under 80 minus 70 minus 70, right? Okay. So what is the angle? So this is not 90 degree. Okay, that will be 40, right? Boleh? So if let's say I want to the second force to be the purple T, how will my diagram look like? Okay, so I draw W first. W. Okay, the purple T I need to draw behind here. Okay, so the angle, need to be careful. Where is the angle? So same as just now, need to refer to the original diagram. So this is the T, purple T, right? So to the horizontal is 20. So means that to the horizontal here, this is 20. So what about inside? 70. Okay, correct. So this is 70. And then the red T, I need to draw behind the purple T. So means that I draw like this. My diagram is not in scale. So this is not in scale. But when you label the angle, so we know how is the diagram look like. Okay. So what would be the angle? So you can label here. What would be that angle? So this angle is the same as here, this angle. Okay. What would be this angle? So can see this is 90, right? So means that here will be 70 also. Okay. And then you can calculate using your mathematics lah. So 180 minus 70 minus 70. Okay. So the angle here is 40 degree. So means that both diagram are correct. So if let's say the question asks you to draw triangle of forces for this system, so there are two possible answer, both correct. And actually you can start with T, not to start with W, but to start with W will be easier way to draw. So let's say you don't want to start with W, let's say you want to start with T, also can. So let's say you want to start with red T, right? So this is the red T. Then followed by W. So W downward, draw behind the first force, which is your red T. So this is W. And then the third one, okay, you draw behind the second force that you draw, like that. So this is your T. Okay, then you label the angle. You will get the same diagram as this. Boleh? But for me, it's easier to start with the vertical. It's either vertical downward or horizontal forces. Okay. Now the third one. So there are three forces acting on the boat, the ship pulled by two tugboat. Container ship. So this is ship being pulled by two tugboats. Uniform velocity, you can see that. So when you see the word uniform velocity, means that the net force are equal 0. So means that the system is having forces in equilibrium. When that happen, so we can draw the triangle of forces. Okay, so first, to draw the triangle of forces, first you need to label the force acting on the system. So in this case, if you see string, cable, string, so there will be tension in that cable or string. So here, this is tension. And here also got tension. Okay, and then the third force is the frictional, the water resistant here, R. So you can see there are three forces, 1, 2, 3. So if you want to start drawing your diagram, your triangle of forces, you can start with this T, no problem, but easier to start with R, horizontal. Okay, so R will be like this. So we don't change the direction now. R is to the left, so still draw to the left horizontal. We normally draw in scale, but in this case, we just practice to draw first. So later if there is a magnitude, then we can draw using scale. So after you draw R, then you draw your T. So I change color to make it easier for you to understand. So let's say this is T like that. Another T, let's say purple lah, downward. So drawing diagram, you need to use ruler lah, T. Okay, so let's say we want to continue with the green T. So we draw like this. Okay, and then purple T, you draw behind the second force. So means that here, purple. Right. See that? We don't change the direction. So R is still horizontal, and then green T, the angle, we don't change. And then T downward like that. But here they give you theta. So where is that theta? So it's actually not that hard. You can see that here, this is the horizontal reference line. Okay, T to green T, theta. So means that here lah, this is your theta. Boleh faham? Can? What about this angle? What angle will be here? To the horizontal. So here, this angle is actually the same as this angle here. What is the angle? Is it theta also? Theta, right? Your mathematics. So let's say these are two parallel lines. Okay. So if this is theta, so means that here also theta. Kan? So means that this angle is also theta. If they give you the angle as 30 degree, let's say here also 30 degree. So this is 30, this is 30. So what will be the angle above? What will be this angle? $120. Okay, so it's at 180 minus 30, 30 means 60 lah. So it's at 120. So this is 120. Clear or not? Jelas? Okay. Okay, now okay. So they normally will give you the magnitude of one of the forces. The favorite one will be W. They normally give you what is W. Okay, so let's say they give you the mass of the frame is 5 kilogram. What will be W? Okay, you need to calculate W by using formula form 4, mg. mg. So M is 5 kilogram, G is 9.81. Okay, you need to calculate this. Okay, to make it easier, I round off to make it easier. But normally we will be using G equal to 9.81. Okay. Oh, Ian already helped to calculate. All right, so 49.05. So when you draw the triangle of forces, so you need to choose a scale. So let's say 1 cm equal to 10 Newton. Okay, so if let's say 49.05 Newton, so it equal to berapa cm? Okay, around 4.9 cm, right? Cm, correct or not? So when you draw W, so the length should be the same as this. Follow the scale that you choose. So means that this W, the length should be equal to 4.90. Okay, your ruler can only read up to one decimal place lah. So means that 4.9. So you need to draw your diagram as accurate as possible. Okay, so this is 4.9 cm, and then the angle, okay, this angle and this angle need to be measured correctly. Okay, let's say the angle berapa just now, 70, right? Yeah, so let's say you draw in scale. So the value of W is in scale will be 4.90 cm. Ruler will be 4.9 cm. Then you measure the angle. Okay, betul-betul cun lah. So here, so you draw here 70 degree, here 70 degree. Then you just draw your line. It's okay to lengthen it. Here also, it's okay to lengthen it. So can see that they will intercept. Alright, so to determine what is T, so you need to measure this length. This length. You measure this length and then refer to the scale. So let's say the length is, you can practice this tomorrow. So let's say the length is, katakan, I just give a number, let's say 5.2 cm. So you refer to this 5.2 cm equal to berapa Newton. So it will be 520 Newton. 52.52 Newton, like that lah. Is it clear or not? Boleh ha? But there is an example here that give you, there are two actually ways to determine the forces. So it's either by using calculation or by using triangle of forces lah. Okay, look at this question. Alright, so the diagram shows stationary lamp hanging from two string. So we have string P and T. Tension T is 8 Newton and the string is inclined at the angle of 60 degree above the horizontal as shown. Okay, so you need to calculate tension P and then the weight of the lamp. Referring to this, so they give you the magnitude of, they only give you the magnitude of T and then the angle. So, and they ask you to calculate, to determine P and W. So there are two ways to determine this. One is by using diagram, another one is by calculation. Okay, so we look at the diagram first. Okay, so first, you need to set the scale. Okay, so let's say 1 cm equal to 1 Newton. Then means that this will be 8 cm lah. Alright, katakan let's say you set 1 cm equal to 1 Newton. So since the magnitude of T is 8 Newton, alright, so you need to draw 8 cm. Alright, so how do you draw T? So since there is an angle here, so you must draw your reference line first. So 60 is 60 degree to the horizontal. So means that you need to draw like this lah. So you draw your reference line, okay, horizontal. So you measure, let's say you start from here. Just draw one, tandakan one, mark one point. So you measure the angle from the horizontal 60 degree. You measure this 60 degree. Then you draw 8 cm length with correct angle. This one must be 60 degree and then the length is 8 cm to represent tension 8 Newton, like that. Okay. So then you draw the second force at the end of the first force. So up to you to choose. It's either to continue with W or to continue with P. Both will be correct. Okay, let's say we draw with W lah. Huh? So you draw W. Okay, 90 degree downward. So this one need to be betul-betul make sure that the angle is correct. So this one must be 90 degree. And you draw W at the end of T. Okay, like that. So it means that this is your W. Okay. Then P will be horizontal. See here. P is horizontal. So it means that P need to be drawn behind W. So you cannot draw like this. If you draw like this as P, this is wrong. Why wrong? Why P here is not correct? Because direction, right? So P should be horizontal. So it means that your P should be here. 90 degree. Okay? Boleh faham? Can understand or not? Okay, so I redraw the diagram. So means that this is your T. You draw your W. And then P. So this is 90 degree. And then the angle here must be correct, 60 degree. And then this length must be 8 cm. Okay, and then what would be this angle? 30, correct. So it means that if you want to draw W at the end of T, this is your T, right? So you need to measure the angle here must be 30 degree, like that. Then since the question asks you to determine the magnitude of P and W, right? Okay, determine magnitude of P and W. So just measure this. You measure this length and then refer to the scale. That will be the magnitude of P. And then to know what is W, you measure this length and then refer to the scale. Okay, that will be the value of W lah. Okay, so they give you the solution down here. Okay, boleh faham? So from if you draw your diagram correctly, so you will get P, the length of P is 2 cm. And then in this case, they use scale berapa? Yeah, here, 1 cm, 2 Newton. Okay, so when the length is 2 cm, so times 2, you will get 4 Newton. If you use 1 cm equal to 1 Newton, so you will get P equal to 4 cm lah, like that. Boleh faham? Same to W also. Okay, you just measure this length and then refer to the scale, you get that. That is by drawing. Okay, drawing diagram. Scale, drawing, triangle of forces. Some question they just open up to you to choose what method. It's either calculation or drawing. So in calculation, we can also determine by calculation. It will be more accurate actually, but it depends on the question. If the question asks you to draw, you need to draw. Okay. So in this case, so the system is in equilibrium. So means that the net force is equal 0. And we know that the object is not moving, okay, stationary. So actually we can resolve the force, okay. So you see, we have 3 forces, right? So this is another method by calculation. So we have W 90 degree downward, P horizontal to the right, and then T there is an angle. So we can draw like this. Boleh faham? Kurang faham? Okay. I redraw here. So you see we have an object. the lamp is here. Let's say this is the lamp. And then we have P. The angle is 60. This is T. T is 8 Newton. And then W downward. So this is W, unknown. We don't know what is the value of W. And then there is another P pulling to the right. Also, we don't know what is the magnitude. All right. But we know that the system is not moving. In this case, it's not moving. Okay. So what we can do will be to draw the axis. This is what we learned in resolution of force. So we draw the axis. Vertical and horizontal axis. So vertical axis can draw like this. So this will be y-axis. And then horizontal axis. So this will be x-axis. So if you see when you see the tree diagram now, when you see the three forces now, obvious P is following x-axis, horizontal. And then W is following y-axis. So it means that you don't need to resolve P and W because P only have horizontal magnitude, horizontal component, sorry. And then W only have vertical component. But T, this is your T, right? T now, which is equal to 8 Newton, can be resolved into two components, vertical and horizontal. See here? So I can do like this. Okay, so I mean that this is the vertical component of T. So I can label as Ty. Boleh faham? And then here, okay, so here. Alright, this one is the horizontal component of T. I label it as Tx. And can see that for now we can look at the vertical component of resultant force, which is the combination of Ty and W. And then for the horizontal component for the net force, so it will be combination of Tx and P. And then again, the system is in equilibrium, which means for this case, the lamp is not moving, stationary. So if stationary means that this horizontal component net force will be equal 0. So do you see that Tx and P now is in opposite direction? Kan opposite direction. But we can conclude that P, okay, P will be equal to, I can do like this, Tx is equal to P. How come like that? Because the system is having zero net force, zero resultant force. Boleh kah? So can see that T and P, Tx and P acting opposite direction, but the magnitude will be the same. Same goes to the vertical component, which is Ty and W. So I can write Ty is equal W. Okay, boleh? Ty, okay, vertical will be equal to W because the system is having zero resultant force. If you still remember, when we learn in chapter 1.1, so let's say we have two boy pulling, okay, so there is a flag. So when they pull with the same magnitude, like that, so let's say this is 10 Newton here 10 Newton. Okay, so the flag will not be moving to the left or to the right. So we can say that the system is having a zero net force. Kan? Opposite direction, same magnitude, opposite direction. So in this case, we need to look at the horizontal and vertical component because the net force also have two component, vertical and horizontal. Boleh ha? So that's why we can write like this, okay? Ty equal to P, Tx equal to P, and then Ty equal to W like this. Boleh? Now, so what is Ty? This one is from chapter 1.2, resolution of forces. So you know that the angle they give now is 60°, right? We use this angle, Tx is adjacent, means that Tx will be, so Tx equal to 8 cos 60, remember not? And then Ty, this is also Ty. Alright, this is also Ty, same thing lah. This and this is the same, right? So we are using 60°. So Ty now is opposite. So we can use sine. So means that Ty equal 8 sine 60. Alright? So boleh tulis terus. So means that P is equal to 8 cos 60. And then W equal to 8 sine 60. So this is by calculation. You get the magnitude. Boleh? Like this. Here. This is in your textbook. Huh? Alright. So, but in calculation, it will be more accurate lah compared to drawing. What if they give P and W and want us to find the angle? Can also, kejap, good question. So let's say they give you P and W and ask you to find the angle. Which angle? Kejap. Which angle? Is it the 60°, is it? They give you P. Oh, okay. So you can do like this. What you can do will be, if they give you the magnitude will be, so means that this W and P, W and P, they give you the magnitude and ask you to determine the angle. So it means that this and this, okay, can be drawn in scale, and we know that the angle in between P and W is 90°. Alright, so katakanlah, let's say this is, let's say 5 Newton. This is, let's say 4 Newton. Alright, so this is 90°. So you just draw like that. Okay, then you just join the end of P to the initial of W. That will be your T, and you measure the length of T, refer to the scale. That will be the value of T, and then from there you can determine this angle. You can, what I mean is you can use your protractor, so you measure the angle. Boleh. Alright. T has to be given. Not necessary, and that if let's say you already have your W and P, once you already have your W and P, okay, and the angle here we know is 90°. So if they don't give you the magnitude of T, also you can determine T already by using the diagram, but it must be using a scale diagram. Correct, scale diagram. Then you need to do calculation. If it is 90 degree, yes, you can use Pythagoras theorem. Okay, tak apa. We will look at the real question lah. Huh? Alright, the second diagram, second example. Yeah, so the box now, the weight of the box is 50 Newton, stationary. So these are the keyword. When you see the word stationary, so you must know that the resultant force, the net force, okay, is equal 0. So means that here, you can draw the triangle of forces diagram lah. So before that, you need to label the forces acting on the system. So if they give you like this, so you need to draw the force. So number one that you need to draw will be W. Always remember this will be 90 degree to the ground. Where is your ground? Here. So this is 90 degree. Right? So means that this is your W. Must have arrow lah. So W. And then there will be another force 90 degree to the surface that in contact. So these are the surface in contact. What I mean is the surface in contact, the object and the surface. So 90 degree to this surface, like this. This will be 90 degree, right? So this is your normal reaction. All right? You can start drawing from here. You can start from here. Okay? So let's say like that. So this is your normal reaction. And then when you look at this diagram, you know that the box, okay, if it is moving, it will be moving this direction or maybe this direction. Okay, so it can move downward or it can be push upward like that. Okay, so if let's say the motion is downward like this, there will be another force that will be opposite to the motion, this direction. So this is the frictional force. So we can label another one like this. Can draw exactly on the surface of the exactly on the surface that is in contact like this. Or you can also draw like this. Both correct. But normally we draw friction. If it is friction, FR friction. Okay, so normally we draw it on the surface that is in contact lah. But it is not wrong to draw like this. Clear not? Jelas ah? So cikgu padam, I rub off this one. It is not wrong to draw like that. Now, you need to draw the triangle of forces. See? Oh, the first one is asking you to draw a free body diagram. This is the free body diagram. Like this. Already draw for you. Like that. Okay, this diagram is known as free body diagram. Next one. And when you draw the free body diagram, there must be arrow to show the direction of the force, and you need to label the symbol to show what force are you drawing. Then B, by drawing scale triangle of forces diagram, determine the magnitude of the normal reaction R and the frictional force. So you need to draw, first you need to draw the scale triangle of forces. So you have 3 forces already. So up to you to start with which one. But if you ask me, I will prefer to draw W first. Okay, 90 degree downward. So I can draw like this. This will be W. Next one is either followed by FR or R. So let's say we start with followed by FR. So in this case, the angle, make sure it is correct. FR. And then R we draw behind. And can see, right? The direction, one-way direction. It does not collide. Clear not? So the arrow jangan terbalik. That would be wrong. So this We really need to follow the correct direction lah, like this. We don't change the direction. Still the same. Still the same. Okay. But be careful, can see here the angle is 40 degree. So where is this angle 40? So then you need to look at here. Can see? This is 40, right? Then what would be this angle? This should be 90. That means that this theta, how much is that theta? Yeah, this is 50. Means that here, this is 90 degree. So this alpha, how much is the alpha? How much? Yeah, 40. Boleh faham? So I can draw like this. Don't confuse. So here, so here is 40, right? And then we know that this is 90 degrees. So this is the triangle. Some student don't really macam confuse here. Alright, so this is 90, this is 40, means that this is 50. So I can draw here 50. Alright, and then this is 90 degree. 90 degrees. So if this is 50, so it means that the other angle should be 40. So look at the diagram that we have drawn. So I just continue this. So it means that this will be the same direction as your R, right? So here. So this angle is 40. Boleh? Can or not? Okay. Now what is the magnitude of this angle? What is that angle? So here is 90. So here is 50. So this is the tricky part lah, because you need to have your mathematics skill lah here. Now what is the angle in between R and FR? 90, correct. Then you can confidently label like that, 90 degree. But where do we get that angle? It is from the original diagram, from this diagram. So need to be careful with this. Okay, so boleh? Can or not? So when you draw your diagram in scale, so you can see here the weight is 50 Newton, right? So means that let's say you are using scale 1 cm equal to 10 Newton. So means that this W need to be drawn with the length of 5 cm lah. Okay, because this represent 50 Newton, like that. So you draw your W 90 degree downward. So this is 5 cm, which will be equal to 50 Newton. Then you measure the angle. So here 40 degree, here 50 degree. Then you draw, so after you measure the angle kan, so you draw this. It's okay to draw it longer. Okay, and then you draw this with the correct angle. It's okay to draw it longer. Okay, so now we know this is R, this is FR. So you just measure this. You measure this length and refer to the scale. So this will be your R. And then you measure here and refer measure accurately lah, then refer to your scale. That would be FR. So with that, you can determine the magnitude of R and FR from your diagram. Is it clear? Jelas? That is explained here. Now, this is another way, but they are using macam reference line lah, 40 degree. Sama lah, it is actually the same as what I explained, but here they draw this as the reference line, they measure 40 degree, but here is actually 50. So up to you to draw, is either you measure here 50 or you draw a reference line that will be 40 degree here. Boleh? You try to practice. Tomorrow you try to practice. Do the same question. Okay. Close the answer and try to draw yourself. Okay, next one. This is another method. They still ask you to determine the normal reaction. Determine the magnitude of the normal reaction FR and R and FR. So means that still determine the same thing. FR, okay, but using different method. So this is using resolve, means that calculation. Resolve W into component parallel to the inclined plane and component perpendicular to the inclined plane. So means that you need to draw the axis. See now? So we can draw the axis on this diagram. So means that this will be the vertical axis, Y axis. And then here, this is the x-axis. So the question asks you to resolve W into component parallel to the inclined plane. So means that you need to resolve this diagram. So cikgu, hopefully I can move this. Can. Like that, Right. Now you can see that R is following y-axis. FR is following x-axis, means that horizontal. Following the inclined plane, that will be your x-axis. Okay, so it means that you don't have to resolve R because it only have y component, and then FR also you don't need to resolve because it only have x component. What you need to resolve is this W. Okay, so you can resolve W to determine this component. Wait, right. So here. So this will be W Y. Why I write WY? Because it follow the vertical component. Kan? But opposite downward lah. Parallel to the vertical component now. So this is WY. And then I can resolve here. Can see? So this will be W following X. So WX. Boleh? So if you want to determine the WX, let's say you are using 50 degree, what will be the value of WX? Let's say you want to use 50 degree. So it will be W cos or sine? Cos or sine? Yes? Cos. Okay, why cos? Because of adjacent, right? So can see if you are using 50 degree, WX now is adjacent to 50. So that's why we use cos. If let's say you want to use 40 degree here, so WX, so this is also WX. To 40 degree is opposite. So can use W equal W sine 40. Okay? Can or not? Now WY. So WY equal, let's say you're using 40 degree. WY here. You use 40 degree, let's say. Sine or cos? Cos, right? Because of adjacent to 40. So means that you can write W cos 40. So the value of W is 50. Kan? 50 Newton. So you can do a calculation. Boleh? So now, okay, from this diagram, what will be the value of FR? FR will be equal to WX. Why like that? Because, can see, right? This is FR, this is WX. Parallel, opposite direction. They are parallel but in opposite direction, and the system is not moving. So means that this, either the system moving in a constant velocity or not moving lah, huh? So means that FR equal to WX. That is how you calculate FR using calculation. And then if you want to determine R, it will be equal to this. Okay, again, can see that here is parallel but in opposite direction. So means that the magnitude will be the same lah, because of the net force is equal 0. Where is it? Here. See? FR. FR will be equal to this. Here. Because this is your FR. This is W sine 40. Parallel, opposite direction. Because of the resultant force is 0. And then if you want to determine R, okay, so we look at this lah. So R and then W cos 40. They are equal also. So far so good. Boleh faham? At least you get something lah from here. Last example. Okay, we proceed now. The last example. We can have another Google Meet to solve problem. Okay, give you some problem that you can solve. Showing poster hanging on the wall with string and a nail. So the weight of the poster is 12 Newton. So first question, draw a triangle of forces for weight of the poster and tension. Then you calculate T. Okay, so first you need to draw free body diagram lah. So means that you need to label the forces acting on the system. Okay, so there are 3 forces. So remember to draw W will be always 90 degree to the ground. Okay, like that lah. So this is your W. And then tension in the string. Okay, the angle is given, right? Then draw the triangle of forces. You can start with W, and then your T, and then another T. But what about the angle? Same as what we have discussed just now. Careful with the angle lah. So need to be careful with the angle. So here, so this is 55. How come 55? Because this is 90 degree. So 90 minus 35. So you get this. Boleh? Can or not? Same goes to the other side here also. But this is mathematics lah, not physics. So this is also 55. And then you can actually draw line here. Here is also 90 degree, right? So means that this angle also berapa? 55. If let's say you want to draw another line here, pun boleh. And then the angle here will be 35. Okay, here is 90 degree like that. Then will be easier for you to draw. So let's say now you know that it is easier to start your diagram with W. So W downward. 12 cm. So set your scale. So let's say 1 cm equal to 2 Newton. So the scale is up to you as long as the diagram can fit your paper. Okay, can fit the space given. If the question give you scale, then you follow the scale. If let's say the scale is not given, you decide yourself. Okay, as long as the diagram can fit the paper, that will be okay. Of course, bigger diagram will be more accurate lah, easier to draw. Right, so let's say 1 cm, 2 Newton. So 12 Newton, the length should be 6 cm. So you draw a line, okay, vertical downward. Okay, this is 6 cm. That represent 12 Newton. So this is your W. Then your T. So cikgu boleh label like this, T1, T2. So T1, up to you to continue with which one. Let's say continue with T2. So T2 will be here. But I need to know what is the angle. So which angle should I draw? Is it 35, this angle? 35 ke 55? This angle. To the vertical, right? So this is your T2. T2 to the vertical will be 55. So means that I need to measure 55 degree here. T2. Boleh? T1 you draw behind T2. Draw like this. If you know this angle. If you don't know this angle, it's good to use to draw from the side that you confirm with the angle. So in this case, see here. Alright, so this is 90 degree downward, right? Okay, that is macam your W lah. So can see this is your T1. The angle here is 55. So you can actually easier to draw here. 55 degree. Okay, just lengthen. This is your T1. Clear or not? Katakan like that lah. So lengthen lah. So as long as your angle is correct. Okay, this side is okay to lengthen it, no problem. Okay, tak ada masalah. So here T1. So to know the value of your T, right? This one just now cikgu label T1, T2. Actually, it is actually just T. Kan? T1, T2, same magnitude. So this one is just, I label it as T1, T2 so that you can see it clearer. Alright, so then you just measure the length. Measure the length here, this length, and refer to the scale. That will be the magnitude of your T. Okay. Oh, here is it. Calculate the value of T. Draw the triangle of forces, then calculate. Kejap. Actually here, you can write determine the value of t. If determine the value of t, you can measure the length and refer to your scale. Or you can use another method, which is by using calculation. So calculation, you can, since we already have a triangle, right? And you already have your knowledge using sine or cosine rule. So if let's say the question asks you to calculate, you can use your mathematics skill to determine the value of t. Okay. Because the triangle now have the angle, so can use either this method or this method. Both will be accepted. Triangle of forces. Wait, let me read your question. For triangle of forces, do we need to measure accurately? Yes, you need to measure the angle correctly, accurately. Yes. Yeah, you need to draw really by using scale and then measure correctly lah. The angle and the length must be accurate. Okay, any question? If no question, I think enough for tonight. Okay, so we'll give you some question for next lesson. All right. So make sure you know, okay, what we learned tonight is actually number one. Okay, number one, you must know what does it mean by forces in equilibrium. Okay, this one. What is the meaning of, what does it mean by forces in equilibrium? So number one that you must know is forces in equilibrium is where the net force acting on the system ataupun the resultant force acting on the system is equal zero. And then you also need to know that there are two situations where the net force is equal zero. Means that there are two situations where the forces in equilibrium occur. One is where the object is at rest. Another one is where the object is moving in a constant velocity. Okay, if only two forces acting on the system, we can easily determine the value of the force. It should be equal magnitude but opposite direction. But when more than two forces involved, for your level now, we focus on three forces only, like this. Okay, so if the system is having zero net force, means that the system is in equilibrium, so we can draw the triangle of forces. And when you draw the triangle of forces, the rules, you cannot change the direction. You need to follow the actual direction of the force. Okay, means that when you draw your diagram, the triangle that you drawn, okay, must only have one direction, like that. So if let's say you draw tiba-tiba kan, the arrow here go down, here go up, and this one is like that. So means that the diagram is already wrong. Alright. So for forces in equilibrium, the triangle that you draw will have one direction. And with that, the angle must be correct. Okay. Okay. And the diagram must be in scale. So in terms of problem solving, the forces also can be calculated by using a resolution of force. Okay, means that there are two methods. One is resolve the force, as what we discussed just now. Where is it now? Here, resolve the force. So for your level, normally only one force that you need to resolve, just like this. W, no need to resolve. P also no need. You just need to resolve T. And once you resolve it, you will get two components like this, right? Tx and Ty. So Ty will be balanced by W, means that the magnitude will be the same. And then Tx will be balanced by P. Because you see, basic will be, can see, right? Opposite direction, same magnitude. Right? So, yeah. Another one is, we also learned about triangle of forces before. Still remember or not? When we determine, let's say you have, don't confuse with this one. There is another situation. Let's say we have a ball kicked by two students. Katakan a ball kicked by two students. So direction is like that, let's say. This is F1. Another one is like this. Let's say this is F2. And the ball accelerate. So when the question said the ball accelerate, is it the forces in equilibrium apply or not? No, right? So means that there is a net force. So in this case, there is a net force. So to determine the net force, you can still draw the triangle of forces, but the method will be like this. So you draw one force, let's say F1, but make sure the angle is correct. So let's say this is theta. So you draw your reference line. This is theta. Second force, you draw behind the first force, means that your F2 can be drawn like this. Alright. And the angle must be correct also. Let's say this is alpha, right? So means that this will be alpha. Then, since the diagram is in scale, if you join the initial to the final point like that, so this is actually F net. This is another part. This is in chapter 1.1. This is also triangle, but do you see that the direction are not one direction? Can see? If let's say a triangle of forces for forces in equilibrium, it will be like this. One way direction. But now can see that here, right? Here. So this means the net force is not equal 0. So this one is F net. There is an F net. It is not equal 0. Clear or not? Jangan confuse. And for this case, when the F net is not equal 0, there are two diagram. One is triangle, another one is the parallelogram. When we draw parallelogram, so this is your F1, this is your F2, like that, right? So the F net is here. This is F net, the diagonal of the parallelogram. So this one is chapter 1.1, resolution, resultant force. So be clear about this. Okay. If the question didn't mention scale, triangle, or forces. If the question did not say anything, then you can choose either to draw or to calculate. Okay. But if let's say the question said must use triangle or forces, if you use calculation, I think you will only get the final, the jawapan terakhir lah, marks. So the step will not be given mark because the question said draw, like that lah. Okay. Okay, all right. If no more question, I think we can stop and then see you again in next lesson, okay, for problem solving. All right, I will send question in Telegram now for you to try. All right. So really hope you can understand what we have discussed tonight. If you have any question, just send in Telegram. All right. Okay, thank you. All right. Okay, bye-bye. Okay, good night.